All right, guys, go ahead and pull up your notes out of Schoology, add them in, and we are going to be talking about rocks. I'm sure you're all very excited right now, and to whoever's covering the class, I apologize in advance. All right, so we're going to introduce rocks at the end of chapter 3, and then we're going to spend the next few chapters actually looking at the specifics of each rock type, our igneous, metamorphic, and sedimentary, in context of how they're actually forming on Earth's surface. But to begin, a rock is an aggregate of minerals. It's going to be a collection of minerals, or in the case of obsidian, it can actually be a volcanic glass. So here in the definition it says a coherent, naturally occurring solid consisting of an aggregate of minerals or a mass of glass. So that kind of makes sense then if we talk about volcanic glass. Otherwise the definition seemed weird. Down here on the bottom, I'm going to make reference to each breakout. So coherent means that it's going to hold itself together as a solid mass. When we talk about naturally occurring, we've already sort of discussed that with minerals in the context that it's made in nature, not man-made. So here it says real rocks formed during geologic processes. Of course, we can go and we can make rock candy in class. We don't really think of that as a true rock any more than we think that bricks that hold the building together are true rocks. Yes, they are solid. Yes, there's going to be a mixture of minerals in there. And then the last point here is most rocks are a collection of minerals. I want to keep running that theme over and over again, because when somebody asks you, oh, what's a rock? It's an aggregate of minerals. Over and over again, you'll see that. Now, how does a rock hold together? Basically, there are two ways. Either you're going to have grains that are glued together, what we call cement, or you're going to have crystallization, meaning that it actually formed out of a melt, out of a magma. There was heat and pressure in the case of a metamorphic rock that actually caused the grains to flow together, but then once it cooled, right, they locked in place. So this particular slide is going to note that, right? Your cement, and you're seeing that on the right-hand side with these pink grains that have the gray and the orange. That's the actual cement. That was some type of precipitate that came through and then basically fell into place and glued it in place. I like to think about Rice Krispie treats when I know some of you are like, yeah, lunch. I like lunch too. But right now, let's focus on the Rice Krispie treats, right? If we take a big pot, we put the Rice Krispies in there, and then we melt the butter and marshmallow or sugar, whatever you want to put in there, right? When you pour that over, it's going to seep in and it's going to glue all of those little fragments together. That's what we mean by cement. That's what's happening in a sedimentary rock. Whereas the crystallization, right, this is where as the magma, the lava slowly cools, right, you form different crystals in there. And as you're going to see when we go through igneous rocks, there are a lot of different ways that crystallization can take place. I'm just going to pause for a second, let you guys catch up on that note. All right, good. Let's keep going. So, check this picture out. On the left, you have a piece of conglomerate. Now that's a sedimentary rock, and if you look there, you can see you have large chunks of rock that are then cemented together. That's what I was referring to with that Rice Krispie treat analogy. On the right-hand side, you have a crystalline piece of blue pearl granite. Now, if I was in class today, I'd actually pick up the computer screen, and there's a slab of this granite right underneath the screen. So on your way out, feel free to look at that or the other two pieces of granite across the front. My point here is that you can see the crystals, but they're all blended together, right? There's not like a clear line banding, separating any of those individual grains, because they were all in this mixture that was slowly crystallizing. And these are very large crystals, so it took a really long time for them to form. That's going to be a key point that we'll focus in on when we do igneous rocks. All right, so some quick references. The text, as you guys read and outlined last night, you could see all these different points. I'm going to try and distill it for you just a little. So rocks are made up of grains held together by cement. We're going to call those our clastic rocks, clastic or sedimentary rocks. And that's going to be our conglomerate, our breccia, our sandstone, our siltstone, our claystone. We'll look at a lot of these different examples. By contrast, if we have grains that grew and interlocked with one another, they formed all at the same time, we call these crystalline rocks, and that's going to be our granites, our basalts, our gabbros, even a lot of our metamorphic rocks like our gneiss that we're going to see later on. These are all crystalline. You can see the individual crystals most times. Sometimes really fine grained, you're not going to be able to see the actual crystal, but you can get a sense that they were all formed at the same time. And then we have the rocks that are held together as a glass, and that's where obsidian again. You don't see any crystals, you don't see any grains, because an obsidian cools so quickly that it just shocks itself into place, and there's no crystalline structure at all. All right, so if you need to make any notes on your slide, take the time now. All right. So rocks occur as either bedrock or individual hand samples. You can either walk up to this huge massive rock that's still connected to the earth and look at different features and try and identify it, or we have what we call hand samples, where you can go and pick up a pebble, a cobble, maybe you're super strong and you can pick up a boulder, right? In this sense, you get the idea that there are different sizes and configurations to rocks. Bedrock, I think, is best thought of as an outcrop. And when you're driving down the New York State Thruway, when you're going over the George Washington Bridge, when you see those masses of rock on the side of the road that just create a huge wall as you're going, that's an outcrop. That is bedrock. And you can even find layering in that bedrock, which we're going to talk about. You can find some specialty features. There are even places upstate you find some fossils, although I don't recommend you get out of the car along the thruway to start collecting rocks. It's a little dangerous. The state troopers don't like when you do that. Not that I would know from experience, but let's keep going. So the basics of rock classification. We have three main types of rocks. We have our igneous rocks, our sedimentary rocks, and our metamorphic rocks. But all of them are categorized by how they form, right? So you'll see the word origin, how it was constructed, where did it come from? Igneous rocks are going to crystallize out of a magma or a lava, so we call that melt. Sedimentary rocks, we're going to cement grains together, or in the case of precipitates, You can have rock salt, right? This is going to fall out of solution and make layers. So that's what we were talking about mining salt. Like go up to Buffalo, there's a big old salt mine up there, right? That was all precipitate out of ocean water. And then you have your metamorphic rocks, which are taking any other rock, whether it's an igneous, a metamorphic, or sedimentary rock, and applying heat or pressure to that rock and changing the orientation of the grains, changing the configuration of that rock in some way. So to metamorphose is to change. Oftentimes, younger children will talk about the metamorphosis of a caterpillar into a butterfly, right? It's to change. Right now, you guys are going through a metamorphosis as a new student at Kellenberg. And in the same way, rocks are going to be under some pressure to change when we have the tectonic plates that are pushing together, when you have new material that's been packed on top and it's weighing down. So we'll get into a lot more about metamorphic rocks later on, but I'm going to give you another minute just to fill in any notes that you might need. All right. So these three rock types in this image are showing you the igneous, the sedimentary, and the metamorphic. Not the clearest image, and if I was in class, I would just pass around samples. But on the left, you're going to see the igneous, and you can see that there are grains that are, again, have all been formed and came together at one time. The sedimentary, you should be able to see the individual grains that have been weathered out, right? Sedimentary rocks, maybe I didn't articulate so well before, are typically made of chunks of pre-existing rock. It weathers down over time, and then when they collect together, right, we get this deposition, and then you glue them together, you compress them together in this idea of compaction and cementation, right? Compact to press together, and then cementation to cement, to glue, to bind. Metamorphic rock, you can see that banding that's going on in here. And in fact, if you look at all of that way that it curves, that was because of the heat and the pressure, right? Rocks normally are not going to bend, right? They're brittle, they're solid. But if we apply a little bit of heat to it, we can slowly start to manipulate it. All right, so the fundamental characteristics of rocks. What are we looking at in these rocks that help us to figure out that it's igneous, metamorphic, or sedimentary? So first up, we have grain size and shape, right? The dimension of the grains, the arrangement of those grains tell us a lot about how the rock was formed, what the rock might be made of, its formational environment, and we're going to look at different examples as we go through each one of the next few chapters. It's how we're going to tie it back to the environment or the geologic process. So the textbook used these two terms that are here, equant and inequant. Basically, look at it, the root in there is equal. So if the dimensions in all directions are equal, well, that means that we're going to have a pretty uniform grain in there. And that's the type of thing you would see in a sandstone. That's something you might see in a basalt when we have a consistency. When we talk about iniquant, that's where we're going to see stretched out grains. Maybe it's a metamorphic feature. Maybe you're seeing that in an igneous rock that has formed at different points. Up in the front of the room, there's actually a gray rock with some big xenoliths that are green. It's actually a basalt with xenoliths of olivine in it. So that comes out of Arizona, by the way. Pretty cool feature. But it's this idea that you don't have just a uniform shape. Instead, there are other crystals that are in there. Something must have happened. And that's where that storybook of reading rocks comes in. Other things to talk about are the composition, right? The proportions of different chemicals that make up a particular rock. And as a rock cools, the minerals actually cool at different temperatures and crystallize at different temperatures. So you can learn a lot about the environment that particular rock was forming. And was it deep down in the earth? Was it closer to Earth's surface? Just by looking at the composition of the minerals. Or in the case of a sedimentary rock, right? Do you have a lot of sediments that are rich in calcium carbonate, right? Was that an environment in which the rocks came from an ocean environment? Are you finding shells in the individual rocks? Is it more sandy? Is it more pebbly? Those are all different characteristics that we'll look at. And I'm referencing pebble and shell because that brings up the next point of texture. Texture, the arrangement of the grains, what the grains look like, the size of the grains, all of that now plays into this idea of how do we figure out what a rock is. So take a minute, fill in what you need. I'll remind you that these notes are on my website, probably until Monday. So if you need to go back and look at any of this. Also, you have a test on Tuesday on all of Chapter 3 and Chapter 2.6 through 9. So maybe find a little time this weekend to look over some notes. All right. So let's look at this picture real quick. All right, I was talking about equant and iniquant. You can see here with the equant, they're all around the same size. Whereas iniquant, the shape is not uniform in any way. Right? This is all stretched out over here and then very thin this way. So think about this. Sometimes pictures really help. And this happens to be a metamorphic rock. That's what we call foliation. So the layering has all been bended. And when you get into the detail, right, when we magnify, you can actually see that iniquant grain arrangement. So I'm hoping that this helps those words to make sense. Initially you look and you're like, oh, what the heck does that word mean? Once you see it in a picture, I think it really simplifies it. All right, so another characteristic we're going to look at is layering. And sedimentary rocks very often will have that layering because they typically get deposited, right? Sediments that are going to get glued together get deposited in a horizontal manner. And when we see nice horizontal beds, we're like, hey, this is great. Nothing's been disturbed. When we see sedimentary beds that have been tilted, so they're at like an angle, very common when you're going down the thruway and you see these sedimentary beds on the side of the roads. They're at a slight angle. That tells us that some type of geologic activity has taken place. But layering, in the very simple description, is just seeing that there's this banding texture. And sedimentary rocks, we call that banding bedding. In metamorphic, we call it foliation. And metamorphic rocks in particular, we branch out very quickly as into you are foliated, you have layering, banding, and then, oh, all of these do not have layering or banding. We call them non-foliated. So we'll get into that. Just a quick note. And then, the moment you've all been waiting for, the take-home message. So, if you got nothing out of today's lecture, please go home thinking, okay, geologists have 3 groups of rocks: igneous, sedimentary, and metamorphic, all based on the way that they formed. Each group includes different kinds of rocks and some physical characteristics that are going to help us to differentiate those rocks. And, just on a side note, the outcrops, or these large masses of rock, are one way to go and study the rock types. The other one is to collect hand samples and bring them back to the lab for analysis. In the reading, you did learn a little bit more about the in-depth ways that geologists analyze that. That was more for your exposure. I will not test you on the different methods that they talked about. So, right now, break off into your homework, answer those questions that make up the rest of the Chapter 3 review. Please take some time this weekend to prepare for Tuesday's test. And to the teacher that covered today, thank you very, very much. I hope you have a great day, and I will see some of you tomorrow at Open House.